let's look at problems involving motion. Problems that deal with distance, rate or speed, and time are called motion problems. And the formula that's often associated with motion is distance equals rate times time. We're going to need to know that formula in order to be able to solve these problems. Let's look at our first application. On her road bike, Olivia bikes 10 kilometers per hour faster than Jason does on his mountain bike. And the time that it takes Olivia to travel 50 kilometers, Jason travels 30 kilometers. Find the speed of each bicyclist. Now, in a problem like this, there's certainly a lot of information that's being given, and it's hard to keep track of all of it. So I recommend that you begin by making a chart. So let's see what this chart will look like. On our chart, we want to compare Olivia and Jason, our two people who are traveling, and we want to put in as much information that we know about their distance, their speed, and their time. So let's begin by filling this out. We know that Olivia has traveled 50 kilometers. So the distance for Olivia is 50. And for Jason, he traveled 30 kilometers. So we know that information about him. In terms of their speed, we know that Olivia bikes 10 kilometers per hour faster than Jason. So whatever Jason's speed is, we'll call it R, we know that Olivia is 10 kilometers per hour faster. Now in this problem, it doesn't give any information about their times, how long it took them. But we can figure this out because we know from this problem that we see this phrase, in the time that it takes Olivia and Jason. So in other words, their times are the same. We have the same amount of time being used for both of them. Now we still don't know the exact number of minutes or hours that you're traveling, but using our motion formula, we can fill out our two charts here. In order to be able to do that, we use our distance formula. So let's figure out what their times are, but we have to do that in relationship between their rates and their distance. So if D equals R times T, then time must be equal to D over R. And you find that out by dividing each side of the equation by R. So if the time is always the distance over the rate, we can figure out a little expression for their times for both Olivia and Jason. For Olivia, her time is 50 over R plus 10. And I got that because I put her distance over her rate. And for Jason, his time must be the relationship of 30 over R. That's his distance over his speed. Now the reason this is useful is that we can use this information to set up an equation. Here's all their information, and what we know is that Olivia's time and Jason's time are the exact same. So if I write these two expressions and set them equal to each other, I will then have an equation where my times are equal. So I'll do that on the next page. 50 over R plus 10 is equal to 30 over R. Now I have Jason's and Olivia's time equal to each other. And now that I have an equation, I can begin to solve this. Let's first of all make sure we know what R stands for. R is their speed or their rate. It's their speed or their rate. And now we can solve this equation, this rational equation. Let's begin by defining what our restrictions are. R cannot equal the value 0 or negative 10. Now that shouldn't be a problem because we probably will not have a negative speed in this, but nevertheless we should still make sure that we complete that step. And now let's solve this equation. We want to clear the fractions by multiplying each side by the LCM. Here it would be r times r plus 10, or r times r plus 10. Or since this is a proportion, we could cross multiply and set it equal to each other. I'll show you that in the next problem. But let's finish solving this. My r plus 10s cancel, so I get 50r equals, and on the other side of the equation, my r's cancel, which leaves me with 30 times r plus 10. Now we can just continue and solve this equation. 50r equals 30r plus 300. Subtract 30r from each side. 20r equals 300. Divide by 20, divide by 20. R is equal to 15. So the rate is 15 kilometers per hour. And so since it wants to know the speed of each bicyclist, I can go back to my chart and make sure I define this carefully. R is the speed for Jason, and Olivia's speed is r plus 10. So I would say Jason's speed is 15 kilometers per hour, and Olivia's speed is 25 kilometers per hour. Let's look at one more example. Tori and Emilio's motorboats both travel at the same speed. Tori pilots her boat 50 kilometers before docking. Emilio continues for another 2 hours, traveling a total of 100 kilometers before docking. How long did it take Tori to navigate the 40 kilometers? Let's set up a chart, just like our last one. Here we're going to compare Tori and Emilio. And we again want to fill out their distance, their rate, and their time. So let's put in any information that we have. Their distances are given. Tori went 40 kilometers, and Emilio went 100 kilometers. We also know from this problem that Emilio traveled for an additional 2 hours. Emilio continued for another 2 hours. So we don't know exactly how long each of them went, but we know that no matter how long Tori went, which was the t time, we know that Emilio traveled t plus 2. So t represents hours in this problem. Now it doesn't say anything about their rates, okay, in terms of the exact speed, but what we do know is that their speeds were the same. So we're going to do a similar idea to this problem like we did for the last one, except this time we have to do it in a little bit different order because now we're trying to fill out what their rates are. So if d equals rt, then r, the relationship between r, must be that r is equal to d over t. Because if you divide this equation by t, you get d over t. Now let's use the information that's given. For Tori, Tori's rate must be the distance over the time. And for Emilio, his rate must be his distance over his time. And now that we've figured out what these two expressions are for their rates, and we know that their rates are equal, we set them equal to each other and we solve. Just like we did in the last problem when we set the time equal to each other. So, now 40 over t equals 100 over t plus 2. 40 over t is equal to 100 over t plus 2. T represents the time, and specifically, t represents the time for Tori. And now we can solve this equation. The restrictions are that t cannot equal 0 or -2. But that shouldn't be a problem. And now we can solve this by clearing our fractions. But since it's a straight proportion of two equations, we can just cross multiply instead of equal to each other. So I could go multiply these together and set that equal to 100t. Okay, that's the same exact thing as clearing the fractions, since it's a proportion. Now I solve it. 40t plus 80 equals 100t. Sorry, 40t plus 80. And then I subtract 40t from each side. So 80 is equal to 60t. Okay. And then we divide each side by 60. So t is equal to 80 over 60, which is the same thing as 8 over 6, which is the same thing as 4/3. Which is also the same thing as 1 1/3. So the time that it took is 1 1/3 hours. So here, let's go back to the question. How long did it take Tori to navigate the 40 kilometers? The time for Tori is t, which we figured out was 1 1/3. It took Tori 1 1/3 hours.